Hi, I'm Dr. Incognito. In this video, we're going to discuss the Extreme Value Theorem and the closed interval method. So the main problem that we want to solve is to find the absolute minimum and absolute maximum of a given function on a closed interval. So that's the closed interval from a to b. That means that x is going to be bigger than or equal to a and less than or equal to b. The closed interval a to b. So the method to solve this problem is called the closed interval method. And the extreme value theorem tells us that this problem has a solution. It has an absolute minimum and an absolute minimum if the function is continuous. So first, the extreme value theorem. The min and the max are extreme values. So the extreme value theorem says if f is continuous on the interval a to b, then the absolute min and the absolute max exist on the interval. So it's not a wild goose chase. The problem has a solution if f of x is continuous. Now let's just take a quick look at what happens if either f is not continuous or this interval is not closed. Because then there is no guarantee that the absolute min and the absolute max exist. Let's take a look at an example where we have, let's say this is a and this is b here. And let's say we have a simple looking function except that it has a jump discontinuity. So let's say that the jump discontinuity happens here at x equals c, and let's suppose that the height of the open circle is capital M. So I would like to say that the maximum value of the function over the closed interval from a to b is m. I would like to say that, but it is not true that f of c is equal to m. F of c is not equal to m because of the circle here that is filled in. F of c is actually less than m. We'd like to say that m is the maximum value of the function, but the function never quite reaches that value, so it does not count as an absolute maximum value for the function on the interval from a to b. And therefore, the absolute maximum, in fact, does not exist for this particular function. So you can see that continuity is necessary in order to guarantee the existence of a max or a min. The closed interval part is also necessary. You can draw a simple function like a line, and if you don't include the endpoints, let's make this one lowercase m, and let's make this one uppercase m. This function, we would like to say that the minimum is lowercase m and that the maximum is uppercase m. But because the domain did not include the endpoints a and b, I'm looking here at the open interval a to b, then m is actually not a function value on the open interval, and neither is capital M. And so the absolute minimum, both the absolute min and the absolute max, do not exist in this situation. So if you have a continuous function on a closed interval, then the extreme value theorem says you're guaranteed that the absolute min and the absolute max exist. So our problem is going to be to find those things for a continuous function on a closed interval. So in our example, we'll consider the function f of x equals x cubed plus, let's make it a minus 6x squared plus 9x plus 1 on the interval from -1 to 4, the closed interval from -1 to 4. I've chosen a nice polynomial function here, so that's continuous on any interval. In particular, it's continuous on this closed interval here from -1 to 4. And so my theorem does say that this function will have an absolute maximum and an absolute minimum on the interval. Now the question is, how do we find them? So the absolute max and the absolute min, where do they occur? They occur at one of two places, at either critical numbers or endpoints. In any combination. So the min might occur at an endpoint and the max might occur at a critical number, or vice versa. They might both occur at critical numbers, they might both occur at endpoints. In fact, actually, the max or min value could occur at more than one place. So it could occur at a critical number and at an endpoint. So let's look at an example. The example's already there. Let's figure out where the max and the min occur. So we have to find the critical numbers. What are the critical numbers for this function? This function is defined for all x. The derivative of the function is 3x squared minus 12x plus 9, which exists for all x. Critical numbers come in two varieties. We're trying to figure out where the derivative equals 0 and also where the derivative does not exist, or where the derivative is undefined. So for a polynomial function, the derivative is defined for all x. So we want to solve f prime equals 0 then to find the critical numbers. So 3x squared minus 12x plus 9 is equal to 0. Divide through by 3. X squared minus 4x plus 3 is equal to 0. This factors x minus 3 times x minus 1 is equal to 0. So x equals 3 and x equals 1 are the solutions. Those are critical numbers for the function. So they're not necessarily the solutions to our problem. The max and the min occur at either of these critical numbers or the endpoints. So essentially what I'm saying here is that we have 4 candidates. We now have to compare function values. We have to compare the function value at the left end, the function value at the right end, and the function values at the critical numbers. So f of 1 and f of 3. Whichever of these values comes out to be the biggest, that will be the absolute maximum value of the function, and whichever is the smallest, that will be the absolute minimum value of the function on the interval from -1 to 4. So if you plug these numbers into the function, what do you get? If you plug -1 in to the function f of x right there, you get -1 plus 6, no, minus 6, then minus 9, and then plus 1. So this is -15. -15. F of 4 is 4 cubed is 64, minus 4 squared is 16 times 6 is 96, plus 9 times 4 is 36, plus 1, 64 and 36 are 100, so minus 96 is 4, plus 1 is 5. At this point, 5 is the biggest, -15 is the smallest. We have 2 more candidates. F of 1 is 1 minus 6 plus 9 plus 1. -6 plus 9 is 3, 4, 5. So 5. We actually have a tie now. So far the maximum is occurring at 2 different places, and the minimum is here. We have 1 more candidate yet to examine. F of 3, 3 cubed is 27. And then minus 3 squared is 9, 9 times 6 is 54. And then plus 9 times 3 is 27. And then plus 1 27 and 27 are 54, so that minus 54 makes 0, plus 1 is 1. Okay, so now we can look and see the absolute max and the absolute min. The absolute max for this function on this interval, the absolute max is 5, and it occurs at x equals 1, which was a critical number, and it occurred at x equals 4, which was the right endpoint. And the absolute min was negative 15, and that was at the right endpoint. So the max occurred in two different places, at a critical number, x equals 1, and at the right endpoint, x equals 4, and the absolute min occurred at the left endpoint. In general, the absolute max and the absolute min will occur either at critical numbers or endpoints. Okay, so this is a look at the extreme value theorem and the closed interval method. Thank you for watching.